teachers, and welcome to this week's video walkthrough of our latest MathFix. Our problem this week takes a look at the standards 6.g.3, which has students working with the coordinate plane and giving points as vertices of polygons. Well, this problem gives students 3 points and asks them to draw a fourth one that would meet the needs of constructing one of 5 given shapes. Well, this is a fairly straightforward problem that has students thinking about the properties of shapes and how to model those by plotting that fourth point of coordinates. Students have been working with images and manipulatives of shapes for a long time, and while these are great grounding for developing properties, it can also lead to some mental images that are tough to break away from for them later on. Well, in this problem, students will see a list of shapes they must make by finding a fourth point, and that will give them an opportunity to really break some of those mold shapes and think outside the box on trying to develop those shapes from the properties they know. Once they have the missing point, then they will also need to prove that the shape is the desired one by again examining the properties of that given shape. With the quadrilateral, the fourth point could be nearly anywhere as long as it is not collinear with any of the two other of the 3 points. Here are 2 examples. Now for a parallelogram, students need to make the opposite sides parallel. So the missing point needs to be at 9, 5. For a trapezoid, they need to really go beyond their images of regular trapezoid, and they can use the point 6 at dot 5 for that one, or they can use any other one that establishes only one pair of opposite parallel sides, and those will likely be the top and bottom sides. Now for a rhombus, they need to have equal and parallel sides, so the point 9, 5 again will give them a shape that has those properties. So this is the same as the parallelogram, really due to the fact that the given sides from the 3 points are already equal. Now for a kite, really again we have lots of opportunities here. 2 sets of equal adjacent sides are needed, and this might prove to be more challenging for the students. The one I like to think about is point 3, 2, seen here, which would give them a concave kite, but it is not really the only possible kite. Other points on a parallelogram will make a kite, a special kind of kite, and you might also look at points 7, 4, which is another traditional kind of view of kites. Well, we welcome feedback on how you and your class engage with this math fix, so please share with us your thoughts, student conversations, or classroom experiences. Likes and feedbacks are great, so please keep them coming as you do this or any other activities within our COP.